I am the professor. The professor. Unlike all others, in this place we stand alone. I am the professor, Julius Sumner Miller. How do you do, ladies and gentlemen, people, men and women, and others? I am Julius Sumner Miller, and physics is my business. And our principal business today raises a paradox about which you must do some thinking. So I am going to put on the board, you must do some thinking about these things. Indeed, I'm going to tell you, there was a young Frenchman by the name of René Descartes in the 17th century, who as a little boy was sick, sort of, and his priest gave him permission to stay in bed in the mornings. And in his later years, when he became a philosopher and mathematician of the first rank, he attributed his success in the intellectual world to the fact that when he was a little boy, he remained in bed in the morning and learned to think. So I say to my students in the class, if you wish to stay in bed in the morning, do some thinking like Mr. Descartes. So, before we get to it, you must wonder why it is I have a flag. Happens to be a Canadian flag. I am going to explain in a subsequent program why a flag flutters. And would you believe it? When I have explained why a flag flutters, we shall learn why an airplane can fly, same principle, why a ball can be thrown in a curve, and I'll throw you a curve in this place. Why birds can soar, why a chimney has a good draft, why boats must not pass too close upon each other on the sea, or trains on tracks adjacent to each other, all connected with a wonderful name, Bernoulli. Oh, how I wish I could take the time to tell you about these geniuses. But anyway, here is our little exercise. I'm going to see if I can make that flag flutter. Oh, wait. Yes, I make flags flutter.
Groovy.
I like it, so I'm going to do it again. And remember, that's why an airplane can fly. Isn't that incredible? So, we must handle flags reverently. Here I have a spring scale that reads from 0 to 2,000 grams. We'll take this slowly. I was going to say we'll take it slow, but you know you need an adverb here. This scale reads from 0 to 2,000 grams. That means as follows. If I put 1,000 grams on it, it reads 1,000 grams. Oh, says somebody, that stupid old fellow. He ought to know it does that. But would you believe it? I do not know why it does it. Because the matter is gravitation, and we do not understand gravitation. All I know is this is pulled down by the earth, and this in turn pulls down on the spring, and the scale reads 2,000. But I have to say more because some of you are bright and capable and thinking sharply, and you're going to say, Professor, are there not some conditions in which it does not read 2,000? Indeed. It reads 2,000 only if the system is at rest or moving uniformly up or uniformly down. Because if I accelerate upward, it reads more, and if I accelerate downward, it reads less. And I would remind you of this. You encounter it when you ride in an elevator. Let me point that out here. Look here. It is wonderful. It is wonderful. There is the elevator cage, and there you are in the elevator, and you're on the ground floor, and in our next program, I'm going to explain to you why it is that when the elevator starts upward, your knees buckle. And when you are on the umpteenth floor and the elevator starts down, your belly feels empty. And that's what I have here, and I'm going to write it as Newton would write it. F equals mg plus or minus ma, to which we will return another time.